don't respect the experience of elders, it's because they don't respect anybody. Okay, we've sort of lost respect for other people's opinions, and that creates a lot of the divisive. That's my lecture on social ills of our day. Are we on? You ready to go? Okay. Anybody have any questions? No questions? Okay. So we were talking about theory of constraints, and I gave the example of the Ford F-150 plant where they were trying to operate it under theory of constraints, where you have some manufacturing bottleneck, some machine or something that slows things down. And I asked the foreman where the bottleneck was, and he says, well, it's the people, where I put the people. It wasn't the machine, it was the people that were the bottleneck. Some people work faster than others. And how, in my opinion, when you had something that was sort of a nearly balanced flow, it's silly to try to introduce a constraint so you could manage it. In fact, there's an important principle there that many of the management gurus and theories are trying to make it easier and just have a simple way so the manager doesn't have to think. Okay, and they can just, at Ford at that time, that plant manager, solve everything with theory of constraints. And I'll give you some other examples of that. There is no one magic bullet. If there was one magic bullet, I'd come up with it and I'd be a rich man. Okay? The managers get paid. Well, actually, why do managers get paid more than hourly workers? That was a question. It was a big question in my mind when I first graduated and went to my first job at Bethlehem Steel Corporation, and the managers had better benefits, better pay, better everything. And I thought, why do they treat the hourly workers as a lower class of society? I mean, why? Does anyone know why managers get paid better? I did learn. Because you never leave your job as a manager. At Bethlehem Steel, we all had to punch in and punch out on a time clock. But when my technicians punched the time clock, they went home and they didn't think about anything else except what they wanted to until they got back on the time clock. As a manager or a supervisor, I was always burdened. No matter whether I went on vacation with my family, I was always still thinking about how could I help solve some of these problems back at work. So managers are paid to solve the big problems, and there is no magic bullet. You can't just sort of give up all your responsibility and think you're going to get good pay for not thinking. Okay? But that's what a lot of these people think they can do. There are times, though, to get back to theory of constraints, when it works. And I've got two examples. I always find some reason to pass around this touchy-feely, which is a turbine blade that I got at a Pratt & Whitney plant in New Haven, Connecticut. This plant makes vanes for the engines. 40% of Pratt & Whitney's profits come from 20% of their business of making vanes. Okay, the rest of it's making the whole engine. But the vanes are only 20% of the engine, but they get 40% of the profits from it. So there's a lot of technology in making that vane. And it turns out in this factory, you have the incoming castings, okay, and they have to be machined. And the tail end of that casting, I used this one because this is called the Christmas tree. You can see that on the side it sort of has arms going out. That has to be machined very precisely. You cannot do that on any regular old milling machine or lathe or anything. Well, it doesn't fit a lathe, but it could fit a milling machine. But you cannot get the precision. You have to broach this. Anyone know what a broach is? A broach is a tool that, well, you ever seen a tap and die? And it's a machined piece, but in a broach you basically, or we talked about reamers before, it's sort of like a reamer, only you push it through to make a very precise hole. You're actually machining by shaving the material. Your tool has a bunch of cutting edges on it, and when you push it through, it leaves a very, very precise hole or other shape. Well, these things are spinning around at 20,000 RPM or whatever, depending on the size of the engine. And if you get any vibration in this, it's just a mechanical interlock, any vibration, You'll get fretting wear, which causes the thing to eventually fail, and fatigue and other things. You have to make a mechanical joint that is near perfect, okay? So the machine that would do the grinding or broaching of this very precise shape of the Christmas tree was I don't remember what it cost, but let's just say it was a $200 million machine, and they only had one of them. And they had all these other little areas where they were doing the other pre-prep or post-prep machining to make that blade from a casting. And it always had to go to the center machine. They'd put the machine right in the center of the building, and they had reorganized it into cellular manufacturing. Okay, and they had done a study to show one of their constraints they had worked on was trying to make the parts take the shortest path through the factory. From coming in the back door, going out the front door, they didn't have to go crisscrossing in a zigzag pattern. They wanted to have cellular manufacturing, but it all surrounded this one machine that you couldn't afford a second one of. Okay? And you had to do the maintainability of that machine because everything depended. When that machine went down, you were out of production to a certain extent. So that was one where you manage that big machine and the process will work better. You don't let that machine go down because that is controlling your throughput. All your throughput, you can have 1 million cells out there, but you're only going to get the throughput through that one machine. Another example, I was had a student at a Ford plant once, and he was looking at painting of the next generation of Ford Taurus bumper. It was going to be polypropylene oxide was the polymer, very difficult to get adhesion, and he was going to have to work that out. But in that plant where they were making bumpers and painting them, and this is just an automotive paint line, and they're curing, ultraviolet curing of the paint here, the paint line was $200 million investment. They only had one of them. And you could have all the injection molders for bumpers, and you could have all the things that might process the plastic surface, but you still had to manage that paint line because that controlled the throughput. So these are two examples where theory of constraints works. But there's many other examples, like the F-150 line, that theory of constraints doesn't work, okay? So then, because people come up with these ideas, some of which have good scientific basis, such as Six Sigma. Six Sigma is a form of statistical process control. And it turns out people looking for work will create entrepreneur jobs, okay, for themselves where they teach Six Sigma. And I get business cards from people when I go in industry, and sometimes it says they are a six, on their business card they have this little symbol saying they're a Six Sigma black belt. It means they took a course because none of the universities were teaching it. Someone would teach this continuing education course and teach them how to do statistical process control, and they passed the quiz, and now they're a black belt in doing statistics for manufacturing. And it's actually something of significance. It means they passed a particular skill set, and here's the certificate they get. And you go into someone's office, and many times that plaque is on the wall, and they're very proud of what they've learned to do. And that's justified. It turns out Goldratt and the goal, which is theory of constraints, doesn't do it exactly the same, but if you remember the picture of Herbie, well, there's Herbie. Herbie was the story here, and Jonah was the consultant to the man who was trying to run the factory. And so now, Goldratt turned the whole thing into a business of teaching people, and he has institutes around the world where you can go pay a hefty tuition, and they will teach you to be and you'll get to have a certificate, say you're a certified Jonah, right? You've seen these, right? Yeah. Anybody else seen certified Jonahs or certified black belts? Well, you will, okay? I don't know what a certified Jonah knows. If you ask me what is the skill set they learned that someone can take your tuition, talk to you for a few hours, and then pass you on without any increase in your knowledge. So hopefully MIT is not there, but I don't have a whole lot of respect for the idea of a certified Jonah, okay? They're going to go and find the constraint and manage it. Oh, okay. Another tool of TQM is just-in-time. This is part of the Toyota production system, okay? So originally, you basically are reducing your inventory and reducing your floor space by pushing your inventory carrying costs back to your supplier. You say, I don't want to receive it until I need it. Well, in Nagoya, Japan, this was a very important thing because Toyota they don't have a lot of space in some of their cities. And Toyota suppliers, many of whom are affiliated with Toyota, would have to deliver every hour or every 2 hours. They would not have a production quantity of more than 1 or 2 hours of stock. How would you like that if you were at Boeing? Okay, you can't build an aircraft with 500,000 parts with only an hour or two of stock. So it doesn't work exactly for every industry, but it does reduce floor space. It shifts your inventory costs. And there's all kinds of stories of when they have a snowstorm in Nagoya, which doesn't occur very often. I got caught in a 3 or 4 inch snowstorm in Tokyo once in 1980 or so. And I was trying to get to the airport to go home, and it's like an hour and a half bus ride from this bus center, and I got to the bus center, and because it had started to snow, they shut down the bus center. So I'm an hour and a half by bus from the airport, and I wanted to go home. So I found a taxi driver who was willing to take me. It took us 6 hours on the road to get what a bus would usually take an hour and a half. And anyway, I won't tell you the whole story. It was the most expensive taxi ride I've ever had, even now. But in any case, I got there on time because the planes were all late too because of the snow. In any case, just in time, it's not Ford, it's a General Motors story, and this was in the, just west of Cleveland. There's an automotive assembly plant, and they were going to build Chevy Cavaliers. And a new manager came in and says, we're going to do just in time. We're not going to have more than 1 hour of stock for any part that goes on the automobile. And a couple of people in designing this assembly line said, well, we have some bolts, and these are not the bolts, but it was just a nut or a bolt, and they could keep a week's supply in a box no bigger than this, okay? Nope, we're only going to have 1 hour. So you can have a box the size of a pill box, okay, for your prescription pills. And that was what that manager said, and he was going to enforce it, even if it made no sense, because he was using just in time, and that's at the time it was one of the latest and greatest ideas. The point being, you have to use some common sense in applying these things. That's what managers get paid for. There are also a number of examples of quick response manufacturing. One was called in the mid-1990s Agile Manufacturing, and some people at Lehigh University had convinced their congressman from Pennsylvania that they should put millions of dollars into the budget for agile manufacturing. And this was in part because of a rapid prototyping need that came out of the Defense Department in the first Gulf War. Some of you were probably born at the time of the first Gulf War, but you may have still been wearing diapers. But some of you weren't even born in the early 90s. But in the first Gulf War, we said we're going to kick Saddam Hussein out of Kuwait, and we're going to mobilize, and it's going to take us 6 months to get everything over there, and then we're going to attack. And we did. Okay, we got everything together in 6 months, and we attacked in like 4 or 5 days. We wiped out Saddam Hussein's army and stopped just short of George Bush Sr. stopped just short of wiping out Saddam Hussein, because they knew if you wiped him out, the whole social infrastructure of Iraq would fall apart. And his son proved that, okay, by wiping out Saddam Hussein, and Iraq's still sort of a social mess. But in any case, the federal government, the Defense Department in particular, became very interested in rapid prototyping. How could you build something? At the time, we were all set for a war in Europe with tanks and things, or a war in Southeast Asia or whatever. We were not set for a war in the desert. And the helicopters were failing because they would ingest dust, sand from the desert, and within 3 minutes they would just abrade away the whole engine. And they had to develop things called engineer particle separators and stuff. They worked around it, but they realized they were working very fast to solve problems. And when you have a buildup that takes 6 months and a war that only lasts for 5 days, you don't have a lot of time to prototype or to change things. And it took them 6 months to change things over for a desert war that they weren't prepared for. And fortunately, Saddam couldn't do anything about it in the 6 months. But anyway, that was rapid prototyping. And so these guys at Lehigh came up with the term Agile Manufacturing. And they said, well, it'd be wonderful if you could be more agile than your competition. And you could make things more quickly. And then people took that and they ended up calling it one-of-a-kind production. And at the time I said, I don't want to be able to make one-of-a-kind. Because if I can make one-of-a-kind, so can my competitor in Thailand. And he probably has lower labor costs. Okay? I just want to be more agile than my competition. Okay? I want to be able to do things better than my competition. I don't want to be able to make things one-of-a-kind. One-of-a-kind is what should be called the tragedy of the commons. Does anyone know what the tragedy of the commons is? No one's ever heard of it? There was a 1968 paper in Science magazine by this guy, Garrett Hardin, who was talking, he was big on overpopulation of the world. He was an ecologist, and he was also sort of a right-winger, but nonetheless, he had some problems with his political ambitions. But the tragedy of the commons phrase comes from an 1833 article written by a British author who was, the region is called The Tragedy of the Commons. Well, does anybody know, we have Boston Common here, right? Do you know why it's called Boston Common? Because the law, back in those days, was that farmers could come and graze their cows on the common. And it's the common grazing area. Well, it's not really a big problem, but you still have a right to bring your cow. If you want to walk your cow to the common, you can graze them. The law still says you can graze your cow on Boston Common. They may now make you clean up what the cow leaves, but does anyone know why it's called Beacon Street in Boston? You know where Beacon Street runs from the common all the way through the Back Bay? Because before they filled in the Back Bay, it was a bay, and Beacon Street was a causeway that you could walk your cow to the common, and when you came back at night, your cow had to wear a beacon to keep, it was such a narrow causeway, someone else coming might be knocked into the bay if you didn't have a beacon to warn them, and so it's called Beacon Street. You didn't know that? Here you've lived in Boston for months, and anyway, but there was a common, and the tragedy of the commons is today in sociology when people will act in their own self-interest to the detriment of the whole society. So if some people go and overgraze the common, which is why it was tragedy of the commons, then there's nothing for the rest of the cows to eat. So it's the tragedy of the commons. And so we tend to overfish in the world. That's a tragedy of the commons, okay? And there's all kinds of examples, and so now it's a buzzword for people acting in their own self-interest to the detriment of the rest of society. And that's one-of-a-kind production, in my opinion, would be tragedy of the commons. Who can make money when the whole world's at one-of-a-kind production? Everybody. It's like Uber and taxis. It's the tragedy of the commons. You know, the Uber drivers don't make money. It's the managers at the top of Uber make all the money. I don't think the Uber drivers can even cover the cost of their automobile in the long term. Okay, that's a disaster waiting to happen. Okay, although it's nice to have cheap rides in nice cars. Okay, there's lots of good things about it. Anyway, 3D printing. That's one of these things about quick response manufacturing. And why do I put HA in there? Anybody know why I think 3D printing is way oversold? Does anyone know what it would cost if I wanted to make something like that turbine blade, assuming I could get all the properties? What do you think it would cost? If I wanted to make a titanium part about that size, what do you think it would cost in 3D printing today? About $10,000. And people say, this is the new manufacturing miracle. Excuse me? Now, it turns out that turbine blade is worth about $5,000 or $6,000. But that's because it's got properties that you can't get from 3D printing, okay? So it's maybe not the best example, but people are talking about, well, faculty in this department have raised $220 million for some faculty, for a startup firm that's using powder metallurgy for 3D printing, and they're going to make automotive parts. Okay, well, you got a kind of a little hurdle from $10,000 a pound to something that's automotive, which is going to be selling for, on average, about $2 a pound. You better have some really good function. You really have some really good ideas of how to reduce that. And so what are they doing? They have multiple print heads. They have like 20 print heads. Well, that could reduce the cost by a factor of 10. Okay, 10 into 10,000, and you're down to 1,000. You only need another factor of 500, right? So what's your next idea? 3D printing is not all it's made out to be in the popular press. And the tragedy is, and by the way, big firms like General Electric have invested in part of this $220 million venture. There are some, well, the first aspects of 3D printing that were commercialized were medical devices, because people don't really care. I mean, you can sell a little part the size of a golf ball for $5,000 if it's going to help someone walk again, right? So they're medicine or health things are sort of price insensitive, okay? Another thing that people used to do early on, and I'm talking in the early 90s, and it was Ellie Sachs and Mike Sema here at MIT, Ellie in mechanical and Mike Sema in materials, who basically took an inkjet printer and started ceramics and started injecting a glue and making a ceramic part, okay, 3D part. And that was the first time I ever heard the term 3D printing, and it was 3D inkjet printing. Came from an inkjet. They took a two-dimensional inkjet print head, modified it so they could put a slurry or actually put an adhesive, and then they would put a bed of ceramic down, print a two-dimensional object, then move it, put another layer of loose powder down, print that, and they could build up things. You know how 3D printing goes. Now it's all kinds of 3D printing, and it's not just their stuff, but the second thing was pharmaceuticals, okay? You got to get the right drug dose in that pill. 99% of that pill is just carrier. It's calcium carbonate, or milk of magnesia or something like that, magnesium carbonate. That's just a carrier. The drug is only a few drops of something. And the 3D print head was great for putting the right amount of drug into that little pill, rather than trying to mix them the way they used to. So there were some high value added parts for 3D printing. But now everybody's touting it as the manufacturing tool of the future because it's additive manufacturing rather than subtractive. You want to run a race? I'll take subtractive manufacturing any day over additive manufacturing, okay? But, so that's why I say ha, okay? And you can find articles now where people are coming out and actually giving the cost on these things, and they are out of beyond belief. Actually, they're not beyond my belief, but I've been working on similar things for years. Total quality management tools. And now, for coming to class, you get a free $5 book. Doesn't look like a $5 book, does it? I'll pass those around. It's called the Memory Jogger. And the Memory Jogger is they sell them for $5 a piece. You can get a discount down to like $4.25 if you buy 100. And it's something that you can put in your pocket, okay? And it tells you about what a pie chart is. It tells you about a Gantt chart, a histogram plot, okay? So these are some of the tools of total quality management, okay? A pocket guide of tools for continuous improvement and effective planning is what it says on the cover. Or this is a more modern version. Doesn't wear out as much as the old one I gave you. But in any case, and this is the newest one, and it breaks things up into working with ideas, working with numbers, and working with teams. It has 2 pages on a CPK. We talked about CPK yesterday, okay? Process capability and how it's calculated. It has a control chart in there. It doesn't call it a Shewhart chart, which historically was the original name, because Shewhart came up with it. Working with ideas, one example is a Gantt chart, okay? Anyone who's worked in industry knows a Gantt chart, because you have certain tracks of things you have to do, and these are the times or the dates you have to have them done by in order to, right? You're smiling. You've seen them, right? Really sophisticated. Goes back to 1910, okay? This is not exactly new, okay? It's been around for a century. There's the fishbone diagram, also known as the Ishikawa diagram, for this guy in Japan who said, well, I can look at my what do I have up here? He's got management issues, raw materials, working conditions is what it says. I mean, technology, machine, and workers. So you've got management and labor. You've got machines, and you've got input raw material and stuff. All these effects could be affecting the quality of your output. And so when you don't know what you're doing, you draw a fishbone diagram, and you try to isolate where the problem is going to be. So, as with most things, I have a story. And this story comes from Detroit, what used to be called Detroit Diesel Allison. Now it's in it's still in Indianapolis, but it's called Rolls-Royce Aero Engines or something. But Rolls-Royce bought Detroit Diesel Allison from General Motors, and they build aircraft engines. They make all kinds of other smaller engines for other components, but typically turbine engines for industrial use, okay, whether it's aircraft or something else. And they had a particular problem, and I can't tell you which engine it was, but they had 13 unexplained failures, 1 or 2 of which actually killed a couple of people in an aircraft. The others, the aircraft was able to land before it crashed. But they didn't really understand these failures. And it was part of the turbine disc system. And these 13 failures had occurred over about a 10-year period. It wasn't something that was falling out of the air every week. And they had made hundreds of thousands of these components. And they've only had these 13 failures, but they were unexplained. And that bothered the manufacturer of the aircraft, who was buying these engines and putting them in their aircraft. It's just not a safe thing to have unexplained failures. Okay, so they put together I think they called us a blue ribbon team, and they had a number of consultants from the outside. They had internal consultants from the aircraft manufacturer. They had internal consultants from Rolls-Royce, and they brought us together for 2 days. And they had this. It was a good-sized conference room. It was probably 10 times the size of this room. And they had charts all over the wall. And one of them was a wall as big as this front wall with a huge Ishikawa diagram. And on the afternoon, I think, of the first day, they had someone scheduled to go over this for an hour, this Ishikawa diagram, and all the things that were on there, and talk to us about all the fish bones on the Ishikawa diagram. It's sometimes called a cause and effect diagram, too. Did I put that up there? Anyway. So they were about to do this. It was a little bit after lunch. And as this person was about to get up and they were about to introduce him, I said, I raised my hand. I was like one of 10 people on this panel. I said, can we not discuss the fishbone diagram? I said, I know that it's a useful tool when engineers are trying to convince management that they've thought of every possibility. But if you're trying to figure out what the real problem is, it's just a waste of time. Okay? I mean, if you're really trying to get down to the root cause, why do you want to talk about 100 possibilities? Why don't you use your expertise to focus in on the probabilities? And so I kind of fairly forcefully said, you're wasting my time. I didn't say you're wasting my time. But the manager at Rolls-Royce, who was kind of introducing this person, was sort of taken aback, and it was about time for a break. Says, well, let's have a break. We're ready for our afternoon break, and then we'll come back. And a bunch of engineers from Rolls-Royce came up and said, we're so glad you said that. Okay? Because they knew. I mean, it's a good thing when you don't know what you're doing to just put up all the possibilities. It's called brainstorming sometimes. This is just one method of brainstorming. But if you're actually trying to focus in on a real answer, it's not really all that useful. So it turns out we came back, and several of their people then felt empowered to go and tell their management bosses that they agreed that it wasn't really that useful to spend an hour and a half. I would have fallen asleep. It was just after lunch. I mean, I'm going to sit there, well, you know, it's just deadly, okay? So again, you have to start thinking about, some of these things have uses, but they're not universally useful. You have to think about when they apply and when they don't. So we come up again with, is TQM for real? Okay? At one level, TQM is a series of buzzwords. And if you are getting the impression it's a series of buzzwords, it's probably a waste of time. Okay? At another level, it's a set of problem-solving methods and tools that can be an important part of engineering. Brainstorming is an important part of engineering when people share ideas and teamwork and all this other thing. TQM really involves people and management of people. Okay? I think I said before in here, 95% of all problems in industry are people problems. They're not technical problems. At the root of the problem, it's people. You worked in industry? So do you agree with that statement? You do. Have you worked in industry? No. You've worked in it, huh? You agree with that statement, that it's people problems? Have you worked in industry? No. Okay, so we got 2 and 2. Actually, our videographer, have you worked in industry? You agree that people are the problem? Okay. So the reason the CEOs, Jack Welch and Ray Stata and these other people, were interested in TQM, it basically was trying to teach the principles of Douglas McGregor, theory X and theory Y. You really want to empower your workforce to do continuous improvement. I can string together all the buzzwords of TQM, but it really gets down to getting everyone united in working out the problem themselves, rather than having someone try to pass it down from on high and order them to do things. Okay? I have stories of the theory X failures, but I don't know if I want to spend time on those. So what I've tried to present to a certain extent here on TQM is it's sort of a conundrum. Is it good or is it bad? Is it for real? Well, turns out a quote that I learned in the early days of the LFM program from someone was from Scott Fitzgerald. The test of a first-rate intelligence is the ability to hold 2 opposed ideas in the mind at the same time and still retain the ability to function. Is TQM good or is TQM bad? The answer is actually both. It's a little bit of both. And how are you going to deal with it when you go out there into the real world and you start getting some business school buzzword guru or some consultant start buzzwording at you, can you bring it back to something that's real and tangible and has real engineering content? Okay? And I know this, the person who quoted this first part to me never quoted the second part, and it was a number of years before I read the second part, because I didn't fully comprehend this until I read what F. Scott Fitzgerald said in this interview following the first part. One should, for example, be able to see that things are hopeless and yet be determined to make them over otherwise. Okay? If it's hopeless, why would you work on it? And you'll hit hopeless problems all the time. I talked about the LFM student who went into the Mad Shitter company, right? The morale was terrible. It was hopeless. So if you take a different tact, buying donuts for the hourly workers, she was able to get things done. The whole management team at this huge corporation had not been able to do for years. Why? Because they had the Theory X attitude that the workers are bad, they don't really want to work, and blah, blah, blah. She basically started treating them with some respect and found that they would respond. What I often say is, I don't know anyone who goes home at the end of the day saying, I did a really lousy job today and I'm proud of it. They go home and saying, I did a really lousy job today at work because they wouldn't let me do anything else. I was trying to tell them how we could do it better, but they wouldn't let me. Okay? They shift the blame to someone else rather than taking the responsibility themselves of forcing it on that supervisor that's forcing it on them. Okay? So, is it good or is it good, bad? So here's a cartoon I had on my desk somewhere about your cat, Mr. Schrodinger. I have good news and bad news. TQM is both good and bad at the same time. And that's what Schrodinger's cat's all about. He's alive and he's dead at the same time. So just keep the opposing ideas in your mind at the same time, and you'll be able to deal with it. I do have a couple of other things beyond this. Does anybody have any questions before I can fill the time, believe me. Okay, and by the way, this is only my 5th lecture, but I'm gone all of next week. So Brian Homan will be lecturing on an example of the Sioux City, Iowa crash and the problems of inspection and quality control. Anybody know about Sioux City, Iowa? Again, it was probably back in the 1980s, so only a couple of us were alive then, right? But a disc in a GE engine, and I don't remember, it's probably a Boeing aircraft, I don't remember, but it blew up and wiped out both the engines. No, it's McDonnell Douglas, because it had both the engines in the back, on the tail. You've seen these, and they have them in it. It just wiped out both engines when it went, okay? Or, both engines. And so all of a sudden, the pilot had to do a glide into Sioux City, Iowa airport. He did it successfully, sort of like today you talk about the guy who landed the U.S. airplane on the Hudson River or whatever, okay? They made a movie out of it. This, Sioux City, Iowa, was before that, and it turns out it was a titanium nitride inclusion from the casting process that caused a fatigue crack in the titanium disc. And Brian actually, there's a lot of stories about this, but he's got some about how it caused General Electric to redo a lot of their quality control metrics. Okay, you have a serious problem when you get to 5 and 6 sigma. How do you fix the problem and get to a higher level of reliability? Does anybody know what the typical reliability of a jet engine is? A commercial jet engine? They're like 99 and 44/100% uptime. But that 0.66 or 0.56% is actually fairly significant, because it means you'll shut down the engine 1 hour or 1 time for every 200 hours of operating. How many people have ever been on airplanes for more than 200 hours? The odds are they shut down the engine for cause on one of those aircraft you're on. They don't usually come over the announcer and say, well, we just shut down one of our 4 engines because it doesn't work, okay? because some people wouldn't be real happy, okay? But it happens all the time, folks, even though they're 99 and 44% uptime. Actually, I think the numbers I saw 20 years ago were, and they were GE numbers, was 99.37. This is not something they advertise a lot, because some people would be like me and they take the inverse of 99.37 and say, oh, actually I seem to remember, whatever the number was, it was 1 hour out of 300, okay? Or one time out of 300 hours. But I've been on more than 300 hours worth of airplanes in my life, okay? I've been on, anyway. So, in any case, I wanted to talk a little bit about what this course is all about. Brian will talk about Sioux City, Iowa one day next week, and he's got to get together with Steve Lyons, because Steve Lyons will be finishing up his lectures. Dr. Belmar finishes his lectures, his module of 6 tomorrow, and Mr. Lyons will do a full double module of 12, okay? So far as you know, if you're attending all the live ones, we're going all the way through March 13th or 14th, okay? In any case, I gave you at the beginning this article on leadership management and education at MIT. And one time, a few years ago, well, actually, when I was in LFM, I was the co-director, and it was Leaders for Manufacturing. Now it's Leaders for Global Operations. And what do this leaders mean? Okay? And so I kind of thought about it for a while, from time to time. And then I kind of put together some other thoughts, and I wrote this article and called it Leadership, Management, and Education. And I put it in the faculty newsletter, and you can go back and read this, but I started out, I wanted to get a pithy beginning. The world looks to MIT for leadership, and this leadership is not limited to science and technology, as we demonstrated, blah, blah, blah. The kid drunk himself to death, and they gave his parents millions of dollars. He'd only been at MIT for 6 weeks. He drank a fifth of Southern Comfort, 2 hours, and choked on his own vomit, and all of a sudden, this place was in an uproar. And the whole world, we were on the front page of the New York Times, the Washington Post. How could someone from MIT, the best and the brightest, drink themselves to death? Well, your parents taught you how to drink before you got here for 6 weeks. We didn't teach you, okay? But nonetheless, MIT was blamed for it, and they paid millions of dollars to his parents. And I'm sorry he died, but I mean, gifted people aren't supposed to do this, okay? So anyway, the expectations of MIT being better than average are not new. In 1911, Thomas Alva Edison was quoted, "There is no question but the Massachusetts Institute of Technology is the best technical school in the country. I have found the graduates of tech to have a better, more practical, more usable knowledge as a class than the graduates of any other school in the country. The salvation of America lies in the Massachusetts Institute of Technology." Hey! Doesn't that sound good? I mean, it's worth quoting. I don't know why you don't engrave this on the Building 7 dome or something. Anyway, but at the end of that, by sitting in a bunch of boring meetings at the LFM, I had read one night, or one person had given a talk the night before, that Peter Drucker, his management guru, had talked about a leader gets the right things done. And so I started thinking, well, what else can I write down about leaders, what leaders do? They get the right things done. And I'd said before, back in the 1980s, I'd determined that half of what I did didn't need to be done. I just didn't know which half, okay? You got all these tasks to do, and if you just ignore half of them, they would go away, but you don't know which half it is that's going to go away. So you have to kind of pay attention to most of them. A leader can sometimes figure out what to do and what not to do. I determined that a leader does more than is required, okay? I've worked with a number of people, and they want to know what the bare minimum is that they can get by with. And that's fine for them, but they're not going to progress if they're doing the bare minimum, okay? And we could talk about that. They balance professional and personal responsibilities, okay? When I was 43, I was put on the board of a manufacturing company that had $500,000 in sales. They had been around since 1843. A company called Nashua Corporation up here in Nashua, New Hampshire. They started out making making playing cards, so all the cowboys out in the West could have something to do at night. They'd play cards, and Nashua made them. And Nashua was into a number of things, but I remember they hired a new CEO. The old CEO had been there for 25 years, and he had helped save the company from bankruptcy. He was a very good guy. Of course he was a good guy. He's the one who put me on the board. And after we had a problem after 1 year with the new CEO, and it was partly California culture coming into New England culture, and they're not the same, Charlie said, I interviewed him, but I should have interviewed his spouse also, okay? Because she still wanted to be in California, okay? And what I've seen a number of times is if someone's not doing well at home, they're not going to do well at work. They're worried about their children, okay? They're worried about their spouse. They're worried about their finances. And that keeps them from focusing on the job at hand, okay? So people have to be able to balance their both professional and personal responsibilities. If they can't, they're just not going to be able to help other people. They respect the contributions of everyone. I get in fairly early in the morning, and I used to park right here by Building 10 before they started building the new Nano Center, right where the nighttime custodians would check out at 7 o'clock in the morning. And so I'd be walking past them at different times, and I got to know some of them. When I became department head, I took the Chipman room, different Chipman room than this one. We had a little kitchenette with a stove and stuff. And our administrative officer, a guy named Joe Dosey, I said, Joe, this year at Christmas, let's do a breakfast for the nighttime custodians, okay? Because these were hardworking people. And I knew I couldn't do it from 7 to 8 because most of them left this job to go to their next job. They were working 2 jobs to make ends meet. So I got permission from Donna, I can't remember her name, she was the chief of physical facilities, and said, look, we want to do a breakfast for the nighttime custodians. Can you let them off at 6 o'clock and they can come and we'll feed them breakfast? We fixed them scrambled eggs and French toast and all this stuff. And I got up and said, you know, as department head and the administrative officer, I said, we appreciate what you've done this past year, okay? They were so overjoyed. We had the best custodial service in the Institute for the next few years. Every year we would have this Christmas breakfast. You know what the rest of the faculty thought? Why are you doing this? They couldn't figure out why. They didn't know. And most of them that know about it, they still can't figure out why I did this. But we had the best custodial service because all I did was show respect for people who deserve a little respect, okay? I used to say the first things you would notice if these people went on strike would be the restrooms, okay? And the second thing you'll notice is there's no, if the support staff there's no food for lunch, okay? So you have to respect the contributions of everyone. This place would not work. No operation will work without everyone's contribution. They also will contribute to the community as a whole, okay? They're going to provide some service because they've got their own life balanced. They're doing more than required, and more than required involves also the broader community. And the most important thing is perhaps they're willing to follow others when they're not leading. They don't have to be the boss, but they can change things from the lower levels by just being a good example. So, what do you think this course was about? I asked 2 of you ahead of time. It was about leadership. TQM is a form of teaching leadership and helping people work together, respecting people, and knowing how to work together to make the whole system work. Realizing that the ideas of the whole are better than the ideas of a single person. So I hope that's what you actually can take away from the 5 hours of lecture here. Not just the stories, but the fact that everybody's important. So thank you. If you have some other questions about the course, I'll be happy to entertain them. If you have any questions now? Otherwise, see you around.